Hello everyone and welcome back to another Universe Sandbox 2 video, and today we're checking out another one of you guys' solar systems, so we'll be on that in just a sec. So before we begin, obviously I just want to thank everyone who has subscribed recently, because we are so close to 2,800 subscribers now. Let's see if we can try and get it tonight. That'd be quite cool. I think we're about 18 people away from 2,800, so yeah, that'd be amazing. So let's see if we can get that tonight, and then obviously continue with our goal to get 3,000 before the month ends, because that'd be amazing. And obviously next thing I want to say is obviously with these episodes, please only leave the link to your solar systems in these videos, just to keep the comments nice and clean and organised, because some people have posted their solar systems in other videos unrelated to this series, and it is quite annoying when the comments are all spammed up. So yeah, please only post one system per video as well, and if you post one and I never get around to doing it, just repost it on the latest video, and then I should hopefully get around to doing it. Also say that you've been waiting a while just to inform me, so I'll pick your one instead, in case I pick someone else's who has only just made the system, for instance. So yeah, if you've posted one and I haven't done it, just repost it again. Yeah, just want to put that out as a heads up. But anyways, today we're checking out a solar system from Mr. Miss-A-Lot, so I'll leave a link to him in the description like I do in all these videos. But yeah, we are checking out today the tree, was it the let me search out. Let me just quickly look at the comment again. It's called the Tion system. Okay, so it was T-E-O-N. Okay, so yeah, we're checking out this system today. So yeah, let's see what we've got. So let's begin. Okay, so we've also got Tion as the main system, or the main star, sorry. So, oh, this is a very big system. Oh, I'm liking this. Okay, so that's everything. Right, so let's begin. So here is Tion. So this is obviously the main star. So let's check out the comparison with the sun like we always do. So yeah, there's its stats there. So pretty hot in surface temperature, 10,000 degrees, luminosity of 43 suns. Okay, it's relatively bright, 2.4 or 2.57 masses of sun. So this is be like a blue main sequence star, I'm guessing, and something like that. So right there as it is compared to the sun. So very similar to Sirius, I might say. Yeah, there's Sirius there, but Sirius is okay. It doesn't say its luminosity. Okay, well, that's fine. So yeah, there is Tion. So there's our first star. Materials, it's all hydrogen, and yeah, there we go. So pretty cool stuff, and it takes 6 days to rotate. Right, so yeah, there's Tion. Alright, so next up we've got the Tion Observer. So this is a probe. So I'm guessing there'll be some habitable planets here if there's a probe here. So there is here. And is this the Cassini Probe? I think that's the Cassini Probe. So actually, let me check. I want to know. Man-made objects is this one. And yes, it is Cassini. Alright, cool. Right, so yeah, we've got a Cassini Probe here, so it's the Tion Observer, so it's clearly observing the star for, I don't know, radiation and stuff like that, and just analysing how it's behaving, I guess. So there is that. Right, first up, okay, so here we've got our first planet, Elnon. Wow, I really do like that colour, just looking at the picture. Okay, let's go look at this. Oh, I do like that colour combo. That red and light, like peachy sort of colour here, this light red peach colour, that is a really cool combo. It sort of reminds me of Mars, but more of a red version of Mars. So let's just get a comparison with Mars here. Okay, the simulation is paused. So here's Mars. So yeah, there is that. So it definitely reminds me of a Mars sort of planet, but it's obviously hotter. So this would be like a it'd be like a Mercury with a Mars, or no, a Mars with a Mercury sort of temperature. This sort of object. I really do like the color scheme on that. It's definitely like a light peach color with a dark red. So instead of Mars, which is more of like an orangey pink, this has gone for a red sort of theme instead of like the orangey pink. So that is really cool. I really do like that object color. And then we've got C-class ship. So this is a little that's a Juno Probe. Okay, so we've got a Juno Probe. I really do like it when you guys use the probes. It is quite cool to see them. Okay, so Tion A. So let's just get a quick look at this body. So let's actually hit play as well just to see it turn. Oh, it turns unique as well. Very nice. So it's on a tilt, as you can see. Yeah, it's definitely on a tilt. So 411 degrees. This is our Mercury sort of planet. Let's compare it to Mercury. So it's obviously a lot bigger. Compare it to Earth. So it's a little smaller than Earth, larger than Mars. So that is that. So it doesn't reflect hardly any light, only reflects 1%. Here is its composition, and it does have a bit of a magnetic field, it looks like. Well, it has got some magnetic field there, even though we can't really see it. So right, there is that. Okay, cool. And that is everything. So there's obviously its mass and radius, temperature. Okay, so there is there. So we've checked all that out there, and it's 1 AU from the star already. So we're already 1 AU away, and yeah, there is a star in the night sky. Actually, one thing I don't usually do, but let's do it for this planet. Maybe I can do it if you guys want it. Maybe like do it one per one. But let's do this. We never really do this. So let's just get a view of the star as it appears. So actually, where is the star? Star? Oh, there we are. Okay, so there it is there. So let's wait for it to come around again. So there it is there, and it should be popping up any second now, I'm hoping. Okay, so let's slow it down. Let's have a look. Okay, so here it is. So this is sunrise on T on A. So yeah, was that, and I hope I'm saying this correct. I really hope I'm not pronouncing this wrong. So here is our sunrise. That's looking pretty cool. That blue glow is so menacing, and there's a star. So now all of the planet will obviously light up since it is the daytime. And yeah, there we go. Cool little sunrise. Don't need to do this. Should I do more surface views in these videos, guys? Let me know. But yeah, that is cool. So there's our sunrise. But I really do like the colour of that. It's really, really cool. Alright, so let's see what we have next. Okay, so let's put labels back on. So we've got T on A and its little ship around it. So let's see what we got next. Okay, so then we've got a C-class ship over here. So this is just a little probe, I'm guessing, just orbiting the star. So a lot of probes in this one. So there it is there. So there's obviously not much to look at here. It's just a default Juno Probe. So there is that. And then we'll go to the next object, which is another one here. This is a Cassini Probe this time again. So we've got another Cassini here. So let's just a quick look at that. So there is the star over there. Just quickly hide it. So there's the star. Okay, cool. So yeah, I'm liking the use of probes as always. It's pretty cool. So I think this may be the most probes we've ever seen. If all of these have probes around them, it's going to be the most probes we've ever seen. Okay, next up we've got T on B, and ooh, I'm liking the colour on that. So let's see what we got here. Okay, so here is T on B, and that is a very nice looking colour. The red and the yellow with the blue atmosphere. Oh, that is a very nice. Look, and it's quite hot in temperature though, 67 degrees. Definitely somewhere I wouldn't like to live, just because too hot for me. I live in the UK. We're not used to this sort of heat, so oh god, I don't think the UK's ever been that hot. I'm guessing so. 67 degrees. That's very, very warm. Reflects 47% of light, and then there is atmosphere 0.7 ATM, and the star is over there. And planetary cooling system. It's a bowling ball. That's pretty cool, actually. That's a very unique object. That's definitely a thumbs up for me. A planet cooling system. I definitely like that. That is a very cool add-on. That's obviously it's not got much mass, so it can orbit the planet no problem. And there's a star over there. So yeah, the star's not too large in the sky now. I think it's probably a little smaller than what the sun would be from Earth. So there's a view of it over there. If we just turn everything off, so quite a nice view. Quite a cool. This could make a good thumbnail actually. Maybe I'll use this for the thumbnail, but that's quite cool actually. I like the blue cloud with the blue star. That is very nice. Alright, so yeah, there is T on B. So let's just get another little look here. So it's very similar to Earth in mass and radius as well. So there's Earth. Let's see, it's 67 degrees. A daytime here is 6.37 days. There's its stats there. I've already seen those. Composition. There is that. And yeah, this one has a magnetic field. We can actually see this time. So there's its little magnetic field. Right, so there is that. Okay, let's see what we've got next then. So there's that. And then we've got another little probe orbiting it. So there it is there. So A-class ship. So this is a Saturn V piece. Yeah, third station Saturn V. We've got one of those flying around here. What they should add is an international space station. I think that would be a really cool addition. Because if they had space stations, you could actually make proper things around planets, like proper satellite systems and stuff, man-made satellites. That'd be quite cool. Yeah, we need space stations added. That'd be quite a cool little feature to add as space stations. Yeah, I do like the little man-made objects there. They're quite cool. So, right, yeah, there's A-class ship anyway. Then we've got the planetary cooling system. So this guy's huge. This is larger than Mars. Yeah, look at that. It's obviously smaller than Earth as well. So that's pretty crazy, and obviously there's not going to be much to look at materials here, since I'm guessing they're probably not changed up too much. But yeah, there's a planetary cooling system, so pretty cool, nice feature there. So I'm guessing this keeps the planet nice and cool, I guess. So it probably gives it a lot of eclipses, so that probably would cool the planet down slightly when it does pass over. Let's see if we can simulate that right now, actually. So let's let it go all the way around. Okay, here we go. Okay, so there should be an eclipse somewhere here. So let's slow down. Let's watch. So let's see here. Okay, here we go. So it's going nice and slow. We should start to see an eclipse appear. So, okay, any second now. Come on. Anything? We've got, yeah, we are on realistic mode. Okay, anything? So it's about to cross in front of the star. So let's see here. Anything? Any eclipse? No eclipse. Huh? Maybe the man-made objects are slightly bugged with eclipses, because obviously they're not meant to be this large. But that kind of sucks. Oh, I wish it did an eclipse. Let me sign. If we quickly add an Earth in. That's what it should look like. So imagine something like this. I'm guessing that's what the bowling ball's purpose is. So something like this. So when the this area is in the shade here. So when it is obviously look at this. So yeah, when it's behind the the star like this, so the star's not visible, this area would cool down since it's not receiving sunlight. So I'm guessing that's what this cooling system does. But yeah, let me know in the comments if I'm wrong. But yeah, if I am wrong, let us know what the purpose of this is, if it's not like what I said, where it makes a shadow and causes it to cool down. But yeah, I'm assuming that's what it is for. So that's a pretty cool feature there. So yeah, definitely a thumbs up from me for that planet, because that's cool. Okay, next up we've got Tion C here. So this looks like a frozen ice world. So let's see what we've got here. So a frozen ice world, it's at minus 14 degrees. So not too cold, but it's still obviously relatively cold. We could live here at this temperature. Like minus 14 is livable, but obviously not very fun because you'd have to wear a lot of clothes. But yeah, it's got a 1.89 ATM atmosphere. So it's just because it's far from the star. If this was closer, it'd definitely be a water world. So it reflects 33% of light. Composition is there, so it's got 1.53 water. So this ice would be very deep then, so there's a lot of water here. It's got a very high Earth similarity and life likelihood, so that's pretty cool. Actually, we need to go check the other planets and life likelihood at the end. So it's also got a magnetic field there, so that's cool. So yeah, temperature, how does this thing turn? So 21-hour daytime, it's on its side as well, so a little similar to Saturn almost with that. Yeah, minus 14 degrees, and then there's its size, so very similar to Earth again with the radius there. So there is that. Okay, very cool. Then we've got another A-class ship, so another Saturn V here, so that's quite cool. Right, so yeah, this probably is the system with the most man-made objects we've ever seen, actually. And then it's got a very tilted moon here, so Tion C1. So I think this is the first proper moon we've seen around planet, so or around one of the planets. So unless I'm completely dumb. Which I wouldn't be surprised if I did miss one and forgot about it. But yeah, so we've got Tion C1 here. So this is a moon, as you can see. It's looks a little smaller than Mars. Yep, there's it there. Mercury is a comparison. So similar size to Callisto then. Yeah, there's Callisto there. So similar size to that, but it's definitely bigger than Io. Yeah, so there's that. So Tion C1, it's got a black and white sort of theme going on with a blue atmosphere. Yeah, we go. Yeah. That albedo isn't very high, so this absorbs a lot of light, but it just doesn't have the atmosphere to get the greenhouse effect, sadly. Yeah, no life likelihood since there's no water, it's just iron and silicate. And yeah, 2.3 masses of moon, there's its radius as we can see. So yeah, there we go, there's Tion C1. So let's see what we've got next. Okay, so we're taking a massive jump here. So this is currently about, actually let me go back to the planet quickly. Okay, so the planet is about 13 AU away. Okay, so that's sort of Uranus sort of distance, I think. But if we go all the way out here, this one is further than Neptune, 50 AU. And a lot of you guys do like to put gas giants further from the star than the rocky planets. So I'm seeing a lot of you do like our sort of our solar system's theme, where you have all the Rockies closer than the gas giants further away. So yeah, here we got Tion D now. So it's a gas giant tilted, very similar to Saturn with the way it's tilted as well. So let's have a look here. So how large are you? Okay, so a little smaller than Jupiter in mass, in radius, sorry, so Jupiter could completely surround it like that. So yeah, a little smaller than Jupiter. If we just get a look there, there's Jupiter, and then in mass, also about half, just under half of Jupiter. So yeah, there's the gas giant, very cold here. Materials, it's actually got a bit of water and stuff, so it's more of like it's got an ice giant sort of composition going on there with a lot of water. So yeah, there's Tion D. Next up, we've got Tion D1, so it's just a generic small asteroid there. Quite small in radius as well. So yeah, there's Tion D1. Okay, then we've got Tion D2. So let's go look over here. So obviously another small generic asteroid here. Quite a good view of the gas giant though. That's quite cool. So there we go. And I'm liking how all the orbits are all different as well. That's pretty neat. So Tion D3. So yeah, there we go. Yeah, I'm really liking how all the orbits are all slightly wonky and stuff. It definitely has some uniqueness to this. And then we got a object further out, which is a frozen ice world. So sort of like Europa here. So completely frozen ice world with a blue glowing atmosphere. So minus 200. So I think this is the coldest object we've seen so far, excluding the small little ones here. So there's that. So it's got a lot of water. So this is even got even more water than the planet we previously saw. So there it is there. ATM. Yeah, it just doesn't have enough atmosphere to get enough heat from the star. So if we look at the star, for instance, let's just land here. Okay. So if we just look at the star. Wait, star. Where you at? Because the star's over there. So look how far away the star is now. It's probably what the sun would look like from like Saturn or Uranus anyway. So yeah, sort of that sort of distance. So there we go. Okay, how far is this from the planet itself? Motion. Okay, so it's not too far away from the planet. So Yeah, 50 AU though. This is a lot further than Neptune is. So there's that. And then we've got T1D5 out here. So we've got another small object. This is very, very dark here. So I'm guessing this guy doesn't reflect a lot of light. Actually, no, it reflects 35, but a very, very dark surface with a blue atmosphere. Also got an iron and silicate core there. So there is that. Okay, cool. So a nice little object orbiting quite far from the gas giant. So that's quite a cool view actually. Let's just get a look there. So let's land on the surface here. So if we look up, there is our gas giant. So quite a cool view in the sky actually. Yeah, it's quite a cool little view, seeing the gas giant there, and then obviously the star would be over here. Yeah, there's the star there. So yeah, pretty cool stuff. Definitely a thumbs up from me on that as well. Okay, so let's see what we got next. Okay, so there's T on D5. That's all of those done. Okay, so next up we've got T on E. Okay, let's see what we've got here. So another gas giant, smaller than the previous one. This is a little larger than Neptune and Uranus, but the first planet with rings we've seen. So very nice. So also on a tilt like Uranus is, as you can clearly see here. It's got a flashlight just to get a good look of it. So there it is there. So it's got like more of a warm colour theme than the previous planet. So yeah, there is T on E. So let's go back like this. So let's go and check the first moon here. So just a small generic asteroid. So probably an asteroid that sort of escaped the little ring system there. And it's also spinning quite rapidly, so it may have had a collision with something in the past there. So there's T on E1. Then we've got T on E2 here. So also just another little generic asteroid here. So there we go. And then let's see what we got next. So T on E3. So another little asteroid here. So could be captured objects, could be caused by a collision. Because how did this object get on its side? Must have hit something, so made all these rings, I'm guessing. So yeah, similar sort of like theory to Uranus, I'm guessing. So yeah, there's T on E. Jupiter mass, yeah, it's nowhere near Jupiter mass and stuff, so yeah, there we go. 5 times wider than Earth is, or bigger than Earth in radius, so yeah, there we go. That is T on E. Okay, so let's see. Okay, we've got one more. So T on F. I really want to see what that mothership is. So T on F. Oh, and it's a frozen Earth. Okay, so let's zoom in here, see what we've got here going. Oh, and completely dark. It's so dark here. No more sunlight. So obviously, probably an ejected planet. So yeah, the star is very dim now. So yeah, T on F. So let's get a look on you on studio mode. So yeah, it looks like an Earth that got ejected. It's got quite a large moon as well. So let's see here. So yeah, it has the atmosphere. If this was closer, this would be warm. So I'm guessing the story behind this is you can tell by its very obscure orbit as well that something ejected this from the system. This definitely had some sort of collision maybe, or it definitely got too close to a larger object and it definitely was thrown out here. That's probably the story behind this one. So, and it will get colder at some points, but maybe at its closest point it does get some sunlight. But yeah, so T on F. So it definitely has the capabilities to support life. It even has a life likelihood, but it's just so cold here that life as we know it probably couldn't survive. But that's only life as we know it. What about life as we don't know it? Maybe there is some species that have adapted to the cold temperatures and can actually survive here. You never know. So yeah, it's very small as well. Quite definitely a small object. It's probably it's around Pluto sort of range. Yeah, so there's Pluto there. So very, very small. Quite a cool colour scheme. Definitely looks like a frozen sort of mountainous colour scheme with the blue there. So that's looking quite cool. Materials, I've already looked at that before. Temperature. See if this was closer, this would definitely be a warm planet. So there is that, and then it's got a very large moon. So this is definitely sort of a representation of Pluto and Charon, since it's a very large planet, or not quite a small planet, sorry. And it's got a very large moon compared to the planet size. So this is definitely reminds me of Pluto and its moon Charon. So let's get a comparison of Charon here. See, there's Charon there. Yeah, very, very close representation. So if we just pause, there's Charon and there's Pluto. So yeah, you can sort of see it. It probably was based off Pluto and Charon. These two objects here. So pretty cool. So yeah, we've got these two here, and this is also a frozen ice world. Yeah, even if this was close to the star, it probably wouldn't get too hot. But yeah, there's T on F1 with T on F. So nice little unique object all lobbed out here just in the middle of nowhere, very far away. How far away is this on the star? 9,000 AU. So in light years, that is 0.1 light years. So very far, almost 0.2, 0.158. And so there's that. And now, last but not least, what is this mothership? Let's zoom in here. Oh, it's the marble thing again. It's this marble object. So here's mothership. So, oh, very interesting here. Look at this. So, oh, wow. Weaponized C-class ship. Oh, these are weaponized. Okay, are these like the villains of this system maybe? So it's got a weaponized ship there. We've got another weaponized one here. So another, is this a Juno probe? That's a Cassini probe. So we've got a Juno and a Cassini around the mothership here. So it's 2,000 kilometers in radius. So I believe that's larger than what the Death Star is in Star Wars. So it's very large. There's it compared to Pluto. Then a comparison with Mercury. So there is it there. I'll compare it to the smallest exoplanet as well. So almost large enough. Actually, no, Kepler 37b. So it's actually larger than the smallest planet. So this is large enough to be a planet typically then. So yeah, the mothership. So this is that marble object. So if we just go to man-made here. So let's just get rid of that. It is this thing here. It's this. So let's go to marble. Yeah, it's one of these. So if we zoom in on this guy here. Yeah, it's this thing. I've never known what this object is. It's very weird, the marble. But yeah, there it is there. You can see it there. It's really buggy when we zoom in. But yeah, it's the marble. But what is this? Does anyone know what this is? Because it doesn't look like a marble as I think of a marble as those small little round glass balls. But this doesn't look like glass. So yeah, does anyone know what this actually is, this marble object? So that's one thing I've always wondered. Yes, we've got the mothership, then it's got the two weaponized things around it, the two weaponized ships. So pretty cool stuff. But they're looking quite. Look at that mass though. That's a pretty insane mass. Look at that. Still nothing compared to a moon though. But yeah, so we've got some weaponized ships out here. Then let's go to mothership or B-class ship out here. So it's probably one of the. Oh my god, there's loads of them. So I'm guessing the mothership has sent all of these objects into this system. Yeah, because you can clearly see the mothership is completely out of this system. It's like thousands of AU away from the orbit of the last planet. So I'm guessing this mothership is from a different system and it's sent all of these probes into the system, maybe. Is that the story behind it? Yeah, let me know in the comments down below if this is like the story. But that's sort of what I'm picking up from it. Is there like a little story sort of going on here? This mothership sent all of these planets here. Maybe they're colony ships, maybe. But yeah, so there is all of those. So there's quite a lot of them there. But yeah, there is all of the objects, guys. So before we end off, we'll get a quick comparison as we do always. Oh, it's very bright again, so we've also got our gas giants, but I want to quickly check these guys here. So the Earth life likelihood. So Earth's generality in this one is 82, life likelihood is 21, probably because it's quite hot here, so there is that. Then we've got C, which I think had a higher life likelihood, yeah, 66.1. And then we've got my favourite of this whole system, definitely my favourite is this one, 45, so that is that. And yeah, there's the life likelihood for them. So yeah, overall, very, very cool system. I definitely like the usage of space probes, and then the planetary cooler system, that was cool. Yeah, there's the mothership compared to some of the objects here as well. And then this poor planet, I definitely like the theme of having the frozen Earth, like, really, really far away. So we've got all of those, and then we've got the tiny little probes at the very end here. So if we go zoom in on those guys, if I can get to them. Okay, come on, let me there. Okay, let's go here first. Then we go to the probes. Come on, let me go to the probes. Here we are. So look how many probes. This is the most probes we've ever seen in one solar system. None of you guys' systems I've seen have ever had this many man-made objects, so probes in here. It's pretty cool. I definitely like the use of probes. But yeah, overall, my favourite object is this. I really like that. I'm even hit up a save with it. I really do like that object. That is cool. If you don't want me having it saved, let me know and I can delete it. But that is a really cool object. I really like that. So yeah, overall, a really, really cool system. I definitely liked it. So yeah, let us know what you guys thought it down in the comments. I'm pretty sure the creator of this system, Mr. Missalot, he'll be interested to know what you think of his work here, because this is a very cool system here. So yeah, let us know what you think down below, and yeah, as always, make sure to subscribe if you're new. Join us on the journey to 3,000 subscribers. Sorry, yeah, help us on the journey to 3,000, because that'd be amazing. And like I said, let's see if we can try and get 2,800 today, because that'd be awesome. We're only about 18 subscribers away, so see if we can try and hit that. And yeah, that is everything, guys. So yeah, make sure you leave a comment down below letting us know what you think, and yeah, make sure you guys all have a great day, and I'll see you in the next video. Goodbye.